In that science or physics class, if you did not learn, you at least heard about atoms. Everything in our universe is made up of atoms. An atom is the smallest piece or part that any material or element can be broken down into. To better explain this, let's say we have the strongest microscope in the world. This is the strongest microscope in the world. So say we put a certain material, for now we're going to call this material A, under it. The smallest thing that you're going to see is something called an atom. An atom is made up of three different parts. In the center of the atom, you have particles called protons and neutrons. And revolving or orbiting around the nucleus, you have particles called electrons. Protons are labeled with the P and a positive sign because protons have a positive electric charge. And neutrons are labeled with an N. They are actually electrically neutral, so they have no electric charge. And electrons are labeled with an E and a negative sign because they have a negative electric charge. Electrons in real life are a lot smaller and a lot lighter than the protons and the neutrons. But for simplicity, we're going to go ahead and draw them proportional to the size of the protons and the neutrons. But in real life, they are actually, like I said, smaller, a lot lighter, and they travel so fast around the nucleus that they look more like clouds. An important thing to remember about atoms and the charges that make them up is that like charges will repel and unlike charges will attract. What that means is that if you have a proton and a proton next to each other, or an electron and an electron next to each other, they will push against each other and want to split or go away from each other. If you have a proton and an electron next to each other, there's a force that is acting on them that wants them to come closer. So why is this happening? Like I said, there is a force that is acting on these particles. This force is called an electric force. The strength of this electric force depends on how close or the distance between these particles. So the closer that the particles are next to each other, the stronger that the force. So the closer that these protons are next to each other, the stronger that force is acting to want to push them against each other. If they're farther apart, then the force is less. It's pushing on them less. And same thing with the proton and the electron. The closer that they are, the more that they are attracted and want to come closer. The further that they are, the less that attraction is. In nature, everything likes to be in equilibrium, and that's no different with atoms. Atoms generally like to be electrically balanced or neutral, and what that means is that they like to have the same amount of protons as the same amount of electrons, or the same amount of negative charge as the same amount of positive charge. But because electrons are a lot smaller and a lot lighter than the protons and the neutrons in the center or the nucleus of the atom, sometimes these electrons are able to move between atom to atom. So whenever an electrically balanced atom will lose an electron to another atom, this atom will now have more positive charges or more protons than electrons or negative charges. This means that this atom will then become a positive ion. The receiving atom will now have more electrons or more negative charges than protons or positive charges. This means that this atom will now become a negative ion. So positive ion, negative ion.